Hi! In my previous two videos I showed the basics of customizing and extending the Weblogic console. In this video I will show a more advanced extension by adding charts showing monitoring data of all managed servers in the domain using Java, jQuery, the content slider, bx slider and chart.js, which is a modular JavaScript to create HTML5 graphs. When running a scaled out Weblogic cluster, a typical setup will consist of multiple managed servers running on different machines. A load balancer will be placed in front of the managed servers, balancing the connections over the managed servers. Under normal circumstances, a response on a given request will be returned promptly. When one of these managed servers is not working properly, some of the users may experience slow response times while other users are not affected. It might be even possible that other processes executed outside the Weblogic server context are responsible for this performance degradation. So how do you quickly determine which managed server is misbehaving when only some of the users are experiencing performance issues while others are not? In this demo I will show you how you can monitor all managed servers in the domain and easily can visualize deviations. A managed server deviating of the average of all managed servers could indicate that the managed server is in trouble. You can retrieve monitoring data using JMX, DMS or use your own custom monitoring data collector. In this demo I will use an MX bean. The MX bean has some simple type attributes containing a single value and array type attributes. These array type attributes will contain multiple samples of the same single value. The MX bean has besides attributes also some operations. These operations take a sample from a simple type attribute and adds this value to the corresponding array type attribute. The systats MX bean is packaged in the systats war. When the systats ER is deployed or started, the context is initialized. The listener class definition in the web.xml will execute the system info collector executor, and the system info collector executor starts a scheduler which executes the system info collector every minute. The system info collector calls all operations starting with take average on the systats MX bean. So let me install the systats ER and demonstrate some of the MX bean attributes and operations. So let me import the required project first. As you can see here, the systats MX bean implementation has attributes and operations. Like operations, like attributes like get architecture, get the number of CPUs, get load average, and operations like take heap usage history samples, get heap usage history. The context listener is defined in the systats war. And invokes the system info collector executor. And executes the system info collector executor every minute. The system info collector invokes the take average operations on the MX bean. Let me now build and deploy the ER file. And as you can see, the systats ER has now been deployed to the Weblogic server. So let me now demonstrate some of the MXBean features by opening JConsole. And as you can see here, the bean has some attributes and operations. It has simple type attributes like number of CPUs, which only contains one value, or CPU load average, and array type attributes like the average CPU load history. This array type attribute contains one or more values. As you can see, we can now navigate for it. There's only one value. And we can add an additional value by invoking an operation like the take average CPU load history sample. So let's take another sample and open it again. So as you can see, we have now 3 samples because also the scheduler has been invoked. We can now go through the values and see that we have now a history of the CPU load. We have also 2 other operations which do the same, one for the heap usage and the other one for the number of loaded classes. In the introduction I told that we will be using chart.js for generating charts. As you can see here, chart.js requires JSON formatted data to be able to display the charts. So there's a challenge to transform the data from the MBean's array type attributes to an acceptable JSON format for chart.js, which can be accessed from JavaScript. To realize this, 2 Java classes will be added to the console extension, a servlet, jchart.json objects, which can receive requests from the JavaScript, and jchart.json helper responsible for the conversion of the MXBean data to JSON format. Each chart type also needs a slightly different composition of data. Therefore, the jchart.json object servlet accepts an URL variable to determine which data is requested. This servlet then invokes a specific method on the jchart.json helper, which retrieves the data from the MXBean and converts it to JSON. Subsequently, the jchart.json object servlet returns the data to the requester. To be able to add these classes to the Weblogic console, we need a Weblogic console extension. So let me start by creating a web application project. Now the project is initialized. I will add a package structure for the Java classes. And add the Java classes. To make the jchart.json objects accessible from a browser, the servlet container must know which servlets have to be deployed and which URLs are mapped to the servlet. And this has to be done in the web.xml. As you can see here, we add the servlet jchart.json objects mapped to this class and add a servlet mapping to a URL pattern. Now we have added the 2 Java classes. The Weblogic console extension can be compiled and deployed. And now the Weblogic server has been restarted. We can test the servlet if it's working properly. And as you can see, by invoking the servlet, the chart.js helper accesses the MX bean data and converts it to JSON. Now we have added the servlet to the Weblogic console extension and tested it. It's time to add the portlet, visualizing the monitoring data provided by the JSON files. So let me add a page extension to the netux extension.xml. And this page extension adds the book system resources.book to the page location labeled page at a specific placeholder position and layout location. The page is divided in a layout which consists of two columns. The right column is the layout location 0, the left column is the layout location 1, and each layout location is subdivided in placeholder positions. The first placeholder position is 0, the second 1, and the third 2, etc. So we'll be adding a book at layout location 1 and placeholder position 1, and that's in the left upper side here, just above navigation book. Now we've added the page extension, we have to add the system resources book. And the system resource book has a portlet instance. So let me add that one too. And the portlet defines the content, which is a GSP file. So we have to add that one too. The system resources GSP file generates the content and uses jQuery to make the requests to the chart.js object servlet to retrieve the JSON data. Because the GSP page uses bxSlider, chart.js and the extension stackbar, we need to add support for these files for these also to the Weblogic console project. So let me add these 3 JavaScripts to the project. And bxSlider requires some style sheets, so I'll add those too to the project. bxSlider is a jQuery extension, so I'll be adding support for jQuery also to the project. By adding the jQuery, JavaScript, and by loading it in the head GSP file. So everything is in place now. So let's compile and deploy the console extension and see if it's working properly now. And as you can see, a new book has been added here. So let me give it some minutes to load some data. So as you can see here, the MBeans have some data history now, and we can show it here in one of these graphs. The extension has 3 graphs, one for CPU load, and it's a radar chart showing the CPU load per server, per managed server, over a period of 10 minutes. So we have now collected last 5 minutes here, and can see that this server, my server 2, has not exactly or more or less the same load average as the other 2 managed servers. So that could be that there is something wrong on this server. And as you can see here now, it's already correcting itself. The second graph shows you the heap size. It shows you the heap size in percentages of the total heap. So it's only showing the allocation and the loaded classes. So this was in short a demo of how you can add your own live graphs of monitoring data to the Weblogic console. That's it, thank you for watching.